Large language models are truly transformative, aren't they?
Absolutely.
They can spit out amazing text, help us write code, tackle incredibly complex questions. But I don't know, if you're like me, sometimes they still feel a bit like that incredibly articulate, friendly parrot.
Huh?
You know,
Yeah.
full of words, surprisingly clever, but occasionally lacking well, a deeper, verifiable understanding. They struggle to explain why they gave an answer.
Right.
And every now and then, they just make things up. Hallucinations.
Exactly. The hallucination problem is a big one.
Imagine a crucial business decision hinging on an LLM answer that seemed perfect but was subtly, dangerously wrong. Maybe it lacked the full context.
Yeah, that's a nightmare scenario.
That's the kind of thing we're looking to solve today. We're embarking on a deep dive into an innovative approach. It's designed to make LLMs not just smarter, but profoundly more accurate, transparent, and explainable. It's called GraphRag. So our mission today is to really unpack what GraphRag is, understand its critical importance, especially now, and explore the foundational patterns for building successful GraphRag applications.
And what's fascinating here, I think, is that many of the core limitations we see, the reason they feel like those articulate parrots sometimes, it often boils down to a fundamental data problem.
A data problem.
Yeah, it's about feeding them truly good, structured, interconnected data. And GraphRag, well, it offers a powerful, really elegant solution to this. It fundamentally transforms how LLMs interact with information.
Okay, let's dig into this then. Before we get to the solution GraphRag, can you pinpoint the specific limitations? What exactly is it addressing in existing LLMs and maybe even in basic retrieval augmented generation or our RAG systems?
Certainly. The reasons LLMs can feel like those friendly parrots, they often come down to a few key issues. First, they typically lack specific enterprise domain knowledge.
Right. They don't know my company's stuff.
Exactly. They might be brilliant generally, but they haven't been trained on your internal docs, your specific products, your procedures. Second, and this is crucial, they really struggle with verifying or explaining the answers they give.
Which leads
Directly to the widely recognized problem of hallucinations. They confidently present incorrect or just fabricated information. Without grounding in facts, it's a bit of a guessing game.
Okay.
Now, when we look at traditional RAG systems, which are a step in the right direction, but they often rely solely on vector databases, they also fall short in some critical areas.
How so?
Well, vector similarity algorithms, they're good at finding similar stuff, but they typically pull back only let's say, a fraction of the total context available, not the full picture.
So bits and pieces, not the whole story.
Precisely. It can leave out crucial connections. And furthermore, while many modern vector databases are, easy to get started with, they're often not really built for the rigorous demands of enterprise use, meaning enterprise-grade scalability, robust fallback mechanisms. They can lack the maturity you need for critical production applications. And a really key insight, a recent study put it perfectly, vector similarity is not the same as relevance.
Okay, unpack that. Vector similarity isn't relevance.
Right. Results might be loosely related, maybe by keywords or semantics, but they often aren't comprehensive or truly pertinent to the full scope of what the user is asking. And that makes it incredibly difficult to explain why certain information was retrieved. We need something more complete, more verifiable, a system that knows why things are related.
So, if traditional vector-based RAG isn't quite cutting it, how does GraphRag pivot? What unique capabilities does it bring to make LLMs smarter, not just, more talkative?
Right. This is where the magic happens. GraphRag is really all about bringing essential knowledge and context to what LLMs already do well, generating text.
Okay.
Think of it like equipping that friendly parrot with a highly organized, logical brain. You could use the analogy of the human brain itself.
How does that work?
Well, our right brain, it's more creative, good at extrapolation, broad understanding, kind of like an LLM. But our left brain, that's the logical, analytical part. Reasoning, facts, enriching data with precise connections. GraphRag works exactly like that logical left brain, and it's built fundamentally off of knowledge graphs.
Knowledge graphs. Okay, define that for us simply.
At its simplest, it's a collection of nodes, relationships, and properties. It's not just data, it's data with inherent meaning and connections built in.
Which is what LLMs need for real understanding.
Exactly. Understanding beyond just word patterns. To give you a slightly better example than just two people in a car, imagine tracing the complex ownership, maintenance, and operational history of, say, an asset in a factory.
Wow.
The owner, legally, might be different from the operator who runs it daily, and different again from the maintenance team responsible for it. A knowledge graph can precisely model all those distinct, nuanced relationships. You see these incredibly complex real-world scenarios, too, like the Stack Overflow graph. It captures immense amounts of rich metadata, complexity about code, questions, solutions.
Got it. So how does using this knowledge graph evolve traditional RAG? What's the upgrade?
Well, it significantly evolves ARI by leveraging this structured, interconnected knowledge. First, it brings improved relevancy. Big time. It retrieves far more relevant results because it pulls back all related information using graph closeness algorithms.
Meaning it follows the connection.
Exactly. It finds everything directly connected to your query, not just what's semantically similar nearby. Second, and this is a game changer, enhanced explainability.
The why.
Yes. Unlike the statistical probabilities from vector databases, GraphRag gives you crystal clear clarity because, well, we actually have nodes, we have structure, we have semantics we can look at. You can visually trace the exact path of information that led to an answer.
That's huge for trust.
Absolutely. And finally, it allows for robust enterprise features, things like fine-grained security, role-based access, making sure sensitive info only goes to authorized users. The outcome, a system that is context-rich, demonstrably grounded in facts, inherently explainable, visualizable, analyzable, and fully loggable.
So it's a paradigm shift, really.
It really is. We're moving from LLMs as, stochastic parrots guessing at answers towards LLMs as informed reasoners that can articulate why they know what they know. That fundamentally changes trust in AI outputs.
That's a powerful argument. But are there any common misconceptions, maybe overblown expectations about what GraphRag can do? And importantly, what are we actually seeing in terms of adoption? Is this real?
That's a great clarifying question. Look, GraphRag is incredibly powerful, but it's not some magic bullet that fixes a poorly defined problem or messy data instantly.
Right. Garbage in, garbage out still applies.
To an extent, yes. It demands clean, well-modeled data, which is definitely an upfront investment. But the results, they truly speak for themselves. The evidence for its real-world impact is quite compelling. For instance, a Microsoft research paper didn't just show better answers.
Right.
It also highlighted less token costs, so it's actually more efficient to run.
Interesting. Better and cheaper.
Potentially, yes. And another compelling finding, this one from a Data.World study, showed a 3 times improvement in accuracy of LLM responses when comparing RAG on traditional SQL databases versus RAG on graph databases.
3 times, wow.
Yeah, that's a massive jump in reliability. The industry is definitely taking note. Gartner's Hype Cycle from 2024, it notes GraphRag as trending up, actively breathing more life into the AI ecosystem beyond just generic AI or even basic RAG. That points to its growing significance.
And are big companies using this?
Oh, yes. We're seeing major industry leaders adopting this in production. LinkedIn's customer support, for example, uses knowledge graphs to power their systems.
And the results?
It reduced median per issue resolution time by 28.6%. Think about that. A significant improvement in quality and response time for millions of users. The core message is clear. GraphRag is grounded in verifiable facts. It effectively tackles hallucinations by providing that concrete context, and it's being rapidly adopted by major organizations for production apps because it delivers real, measurable business value.
This all sounds tremendously impactful, but okay, the practical side. How do you actually implement GraphRag? Where do you even begin getting all that, unstructured data into this rich knowledge graph format? It sounds like a pretty significant undertaking.
It is a significant undertaking, you're right, but one with incredible returns. It's important to understand the two sides to the coin here. The crucial first step, and where much of the initial effort lies, is knowledge graph construction.
The foundation.
Exactly. It's true that if you want to have higher quality outputs, you have to put in more effort at the beginning, but think about it. This isn't just about better answers now. It's about building a durable, evolving enterprise knowledge base that compounds in value over time. Unlike, say, transient vector embeddings that might need constant reindexing.
Okay, so the upfront work pays off down the line.
It pays off multiple times over. You get high-quality, structured information that allows for robust contextual extraction and truly intelligent retrieval later.
All right, so break it down for us. How do you build this knowledge graph? What are the phases?
Okay, let's break down the three distinct phases involved. The first is lexical graph creation.
Lexical graph.
Yeah. This process involves taking your unstructured information, think PDFs, meeting notes, articles, whatever, giving it substructure, and transforming it into a lexical graph. This graph represents your documents, their individual chunks, and crucially, the relationships between those chunks.
So, like chapters in a book.
It could be simple, like breaking a document into paragraphs, or more complex, exactly like modeling a book which has chapters, which have sections, which have paragraphs. Or maybe each paragraph is the semantically cohesive unit you want to embed.
And the relationship.
That's where the real power lies. You connect these elements, you represent predecessor and successor relationships between chunks, showing their sequence, parent relationships, showing hierarchy. You can also use vector or text similarity, like k nearest neighbor, to create a similarity graph between chunks, maybe with a weighted score.
So you can retrieve information in different ways.
Precisely. This allows for incredibly flexible retrieval based on the document, the temporal sequence, or the similarity of the content. The payoff here is enormous. Instead of flat text blobs, you're giving the LLM a sophisticated map of your knowledge base. It can navigate not just what's said, but how it's structured, how pieces relate, like knowing chapter and verse, not just a keyword.
Okay, phase 1. Structure the documents and link the chunks. What's next?
Phase 2 is entity extraction. This is where LLMs themselves become a critical tool.
Using the LLM to build the graph.
Exactly. You leverage their multilanguage understanding, their flexibility, their strong language skills for precise extraction. The method basically involves giving the LLM a defined graph schema, like a blueprint for the entities and relationships you want to find, and an instruction prompt, along with your text chunks.
And they can process a lot of text.
Modern LLMs, yeah. With their large context windows, they can process a significant amount, sometimes 10,000, 100,000 tokens for extraction in one go. And what's particularly smart here,
Go on.
you can pass in existing ground truth. Things like your existing product list, known genes, client names from your CRM, pass that in as part of the prompt.
Why do that?
Because it allows the LLM to do recognition and finding of existing entities and connect new mentions to your established data, rather than just trying to extract everything from scratch every time.
Ah, so it links new info to what you already know is true.
Exactly. It drastically reduces errors and ensures consistency with your established enterprise vocabulary. I remember a client trying to manually map complex product dependencies across thousands of documents. It was a nightmare.
I can imagine.
GraphRag's entity extraction and relationship mapping just automated months of their work into days, connecting new insights directly to their existing CRM. So the outcome is extracting relevant entities, their relationships, storing additional facts, enriching your graph.
Okay, lexical graph, then entity extraction using LLMs. What's the third phase?
The third phase is graph enrichment with algorithms. This is where you run various powerful graph algorithms directly on your newly built entity graph.
Like what kind of algorithms?
Things like PageRank, maybe, to identify the most important or connected pieces of information, or community detection algorithms.
Community detection.
Yeah, they automatically find and can help summarize groups of related topics within your data. You can also use clustering or link prediction. The purpose is to identify these communities or topic clusters that span across multiple documents.
Finding themes that connect different sources.
Precisely. An LLM can then generate concise summaries for these identified communities. The significance here is that it helps identify those overarching cross-document topics that wouldn't be obvious just looking at individual documents one by one. It provides that horizontal view, tying everything together, uncovering insights previously hidden in the data sea.
Wow. Okay. So you've invested this effort. You've built this incredibly rich, interconnected knowledge graph through these three phases. How does GraphRag actually search it then to provide those context-rich answers? It sounds like it must go way beyond a simple keyword or vector lookup.
You're absolutely right. It's definitely not just a simple vector lookup. The retrieval phase in GraphRag is much more sophisticated, much more intelligent. It typically starts with an initial index search.
Okay, like vector or keyword.
Could be vector for initial relevance,
Yeah.
or full text for keywords, maybe even specialized spatial or hypergraph search. That finds your initial entry points into the knowledge graph. But here's the key difference. From those entry points, the system then actively follows the relationships up to a certain degree or up to a certain relevancy to fetch additional context.
Following the map you built earlier.
Exactly. And this additional context isn't just random text, it's highly specific. It can even be personalized.
Personalize how?
Well, it can be derived from the nuances of the user's question itself, or even from external user context. So, for example, someone from the finance department might get different, tailored information pulled from the graph than someone from engineering, based on their specific needs and roles.
That's smart. Context-aware retrieval.
Exactly. So rather than just returning fragmented text snippets, GraphRag returns a more complete subset of the contextual graph to the LLM. And it's important to remember, modern LLMs are increasingly trained on graph processing. They can actually deal effectively with these node relationship, node patterns as additional context.
So they understand the graph structure itself.
More and more, yes. It makes their answers much more informed, accurate, and truly relevant. They're not just guessing anymore. They're reasoning with connected facts provided by the graph.
This all sounds incredibly practical and honestly revolutionary. Can you give us a glimpse of how this looks in action, maybe some concrete examples, or what kinds of tools are available for this?
Absolutely. For the knowledge graph construction part, from unstructured sources, there are excellent open source tools and commercial offerings out there. Like one from Neo4j, for example, that lets you take diverse sources, PDFs, YouTube transcripts, local documents, web articles, Wikipedia pages, and automatically extract their data directly into a graph following a schema you define.
Okay.
So take an article, maybe about Google DeepMind. Such a tool can process it and clearly show you two connected aspects. One, the document itself structured into chunks, and two, the extracted entities, companies, locations, people, technologies, all connected within the knowledge graph, following that predefined schema.
Visualizing the connections.
Right. And when you want to retrieve information, these tools offer flexible retrievers. You can use vector, graph traversal, full-text search, even entity-specific retrievers.
And the explainability you mentioned.
That's where it really shines. These tools provide deep insight. They can show you exactly which sources, which specific chunks, and which entities from the graph were retrieved and passed to the LLM.
Ah, so you can trace it back.
You can trace it right back to the origin. This leads to a richer response, and you have full confidence in why the LLM gave that answer. We're also seeing more advanced setups, like the agentic approach.
Agentic.
Yeah, where you have domain-specific retrievers, maybe using powerful graph query languages like Cypher. It's a query language specifically for graphs. It lets you precisely navigate and retrieve complex patterns. So these retrievers are used in an agentic loop. It breaks down complex user questions into smaller tasks, extracts parameters, runs individual tools or queries, potentially in sequence or looping, to build up a comprehensive answer.
Like a team of specialist searchers.
Kind of, yeah. And tools like NeoConverse can even output not just text, but also charts and other visualizations, and even network visualizations. That really enhances understanding, makes complex relationships immediately clear.
That sounds incredibly useful. Is this stuff accessible, or is it locked away in research labs?
No, it's becoming very accessible. These concepts and tools, including things like a Graph Python package for building these construction and retrieval pipelines, are readily available as open source libraries on GitHub. You can use them directly from Python notebooks.
That's great to hear. Well, this has been a remarkably insightful deep dive into GraphRag. It truly showcases how we can empower LLMs to be not just smart, but contextually aware, grounded in facts, and remarkably explainable. It really feels like we're moving from just talking at our AI to actually giving it a verifiable, logical brain to work with.
And to reiterate the core value, I think, GraphRag provides that sophisticated structure, that rich context that LMs really need to overcome their inherent limitations. It transforms raw, often chaotic information into actionable, verifiable, and deeply understood knowledge. It really is about building trust in AI by ensuring it can always show its work.
Absolutely. So as you, the listener, reflect on this, here's a thought. What complex, unstructured data in your world, be it internal documents, customer interactions, vast research, what could be transformed into a powerful knowledge graph? How could that fundamentally change how you retrieve and interact with that information?
Just a powerful question.
It is. And if you want to explore this further, you can find many patterns and resources available online. A good starting point is graph.com.